We're doing 2.2 reflections. Um, Reflections are another type of transformation. The previous type of transformation we did in 2.1, and that was a translation. So reflections are similarly though transformation, and we'll see how they're different here. Um, so reflections you can think of as reflecting over a line. We'll always have a line of reflection, and you can think of that as like a mirror or maybe something that something's bouncing off of, something like that. Um, if we don't have any values, so we're not in the coordinate plane, it's pretty tricky. What we have to do is we have to find um, our line of reflection here, say, and if this is our figure that we want to reflect over it, we're just going to focus on those points. So we have points A, B, and C. And in order to reflect over it, we need to find a segment that is perpendicular to that line of reflection. In fact, a segment that is bisected by that line of reflection. So we can do this using a compass. You could also do this eyeballing it, although let me warn you, it's really easy to mess up if you just quote unquote eyeball it. Um, uh, I'm going to run you through my little technical way, um, but just know that those are the other two ways that are usually pretty good. Um, so my technical way is to look at the slope of this line of reflection. In this case, the slope is rise over run, right? In this case, -1 over 1 or -1. So the slope is -1 for this line L. In order to find a line that is perpendicular to it, you need to find the opposite reciprocal. So it's a big fancy word of saying whatever this is, I'm going to make it negative. So a negative negative is a positive. And then I am going to make it a fraction by putting 1 over whatever it is. Or if it's already a fraction, I just switch the numerator and denominator. So I'll give you a couple examples, but for starters, we'll just focus on this one. The opposite reciprocal of this -1 slope is +1, right? So because we switched the sign, and then 1 over 1 is still just 1 over 1. So this gives us the slope of this segment here, which is perpendicular to our line of reflection. So the line of reflection, we can also think of the slope as going, down 1 over 1, down 1 over 1. This one, it goes up 1 over 1, up 1 over 1. So in order to get from point A to that line of reflection, we go up 1 over 1, up 1 over 1, or up 2 over 2. And then we have to go exactly that far again. So we'd go up 2 over 2 to get out to there. This is the square root of 8, right? Distance-wise, but we're not really going to measure that. We since we have coordinates here, we can just count 1, 2, and then 1, 2. So that'll give us a point out here that we can call A prime. If we were to do the same thing for B prime, it's still pretty simple. We just go up 1 over 1, same slope here, and then we go that distance again. Up 1 over 1 gives us a B prime. So that's how I'd find B prime. C prime is a little trickier because we have to go up 1 over 1, up 1 over 1, and then up a half and over a half. Because we can't go to this point because that's the wrong slope. We can't go to this point because that's the wrong slope. We have to go to this point right here in order to find, oops, how far away that is. Oh, there it is. So that'll give us basically up 2 over 2 to get here, and then we go up 2 over 2 to get here. So that'll give us point C prime. I think it gives us something like this. Again, you can get each one of those using a compass or maybe just eyeballing it. Note here that you can double check to make sure that you've done a rigid motion. Reflections are rigid motions. The size and the shape stay the same. However, it will be mirror imaged. So in this case, we can look at this and go, what's the length from A to B? Well, it's over 3 down 1. What's the length from A prime to B prime? It's down 3 over 1. So it's the same length. We should double check that anytime we have a few points to check. Okay, I'll do another example. This one again, I'm going to use my my technical method here, which is to look at the slope of line L. we're not really in the coordinate plane, so it really doesn't have a slope, but we'll see here. It's rise over run, right? So the rise is 1, the run is 2, so the slope is 1/2. And so the slope of the perpendicular segments that are being bisected will be the opposite reciprocal. So the slope, put M2, is equal to negative, and you just switch the 2 and the 1, 2 over 1 over 1, or that's equal to -2, right? So anytime I look at any of these points here, I'm just going to go in a -2 slope direction until I hit this line of reflection, and then go that distance again. So we'll see a good example is A. We're going to go on -2 slope, so that's down 2 over 2 over 1, down 2 over 1, and then we hit it, so we go that distance again, down 2 over 1. That puts us right here. B, we go down 2 over 1, down 2 over 1, and then do that again. Boop, doop, doop. Yeah, I got off. Put this here. Put this all the way over here. And then finally C. C is on that line of reflection, so anything on the line of reflection, the reflection is just that same spot. I'm going to go ahead and label it, though, as C prime, because that's where C prime is. This is where B prime is, and this is where A prime is. And again, we can check our transformation here by checking the size. What is C prime to B prime? Well, it's 1, 2, 3, 4, 5 units. What is A to C? Oh, what is B prime to C prime? Well, it's up 1, 2, 3 over 1, 2, 3, 4. So up 3 over 4. This is a 3, 4, 5 triangle. So 3 squared plus 4 squared is 25. Square root of that is a 5. So B to C is 5, and C prime to B prime is 5. So we're doing good there, and we can check the other one similarly. Okay, moving on. Go ahead and try these two. Pause. Hopefully they look something like this. Again, please double check that they're the right size, and they should be equidistant from here. This one has a slope of -2, right? Down 2 over 1. So therefore, these segments have a slope of 1/2. Similarly, this one has a slope of 3. So these segments have a slope of -1/3. I'll write those values down because that'll make it a little easier. This one has a slope of, what did I say, -2. This one had a slope of 3. M equals, and then M2, which is this line here, or this one, or this one, they'll have a slope, or this one has a slope of 1/2. It's opposite reciprocal. And this one has a slope, in this case, of -1/3. So opposite reciprocal for both those. Okay, in the coordinate plane, it's a lot easier in the coordinate plane because they just give us rules. In fact, the only reflections that we'll do in the coordinate plane are on one of 4 possible lines. The first is y-axis, or the first is the x-axis or y-axis. The other 2 are the lines y equals x and y equals -x. Just a reminder, and I'll be really embarrassed if nobody knows this, but it'll happen, don't worry. The line y equals x is simply this line here, right? It goes in a nice perfect diagonal. And then the line y equals -x is something like this. Blink, blink. So be prepared to do reflections over those lines. The cool thing about these is they give us the coordinate notation rules. So all we need to do is simply know the points, and then we can plug them in just like we would for any other transformation. We'll do some examples. This one here, we have points M, N, and P. and then it tells us to reflect it over the y-axis. So when they say that, you can refer back to this chart. I'll give you this chart on any tests, so you don't have to memorize this, but you do have to know how to use it. So we look here, what's the rule of reflection for the y-axis? In this case, we simply make the x values negative. So we can take all our points, we make the x values negative, and then we graph them again. And it should turn out pretty good. Go ahead and do this one. Bosh. Hopefully you got those points. I'm going to go ahead and graph it, see if we get the same thing. So we started with this one, which is that one, this one, and then this one, and then that one. Boink, 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 boink. And then we reflect it over the line y equals x, which I can go ahead and draw. And I should have gotten the points 0, 2, 2, 2, 2, 5, 1, 5. There we go. 2, 2, 2, 2. So it should look something like that. Make sure, is a general habit, you should label your points. I got a little lazy there for the interest of time. Okay, and that's quadrant 1. Okay, a classmate claims that the rule xy becomes negative xy for reflecting a figure across the x-axis only works if all the vertices in the first quadrant are in the first quadrant because the values of x and y must be positive. Why is that not correct? Pause and think about that one. Yeah. Remember, this negative here just means that if whatever this is multiplied by -1. So if it was negative, it becomes positive. If it's positive, it becomes negative. Okay, do these ones too. Okay, hopefully you got something like this. Again, reflection over the x-axis. We simply make the x's negative, or vice versa. And on this one, we switch them both. What's the rule for over y equals negative x? Oh, we switch them and make them both negative. So the whole shebang, right? Reflection over the line y equals negative x, switch the x and y and make them negative. Okay, and then working backwards, similarly to some of these other problems, this one just asks us to draw the line of reflection or find the line of reflection. So if we're given this, it's hard to see. If we're given this pre-image and this image, and then what we would need to do is we need to notice that between each point and its each point between the image and pre-image for each point, that makes a segment, right? So we have segment AA, or A prime to A, and of that segment, we want to find the midpoint, right? That's the line of reflection will go through the midpoint there. Similarly, we want to find the midpoint between B and B prime, and we want to find the midpoint between C and C prime. Once we find all those midpoints, we know that the line of reflection goes through those. You guys should be able to do this algebraically. We'll do maybe an example here in a second. But here graphically, it's pretty obvious. We can also, again, you can get away with eyeballing it sometimes. But you should also be able to double check. So if they give us 3 points, they'll often be 3 points. 2 points is enough, but then the third point is your double check. So if your third point ends up off here and you're like, well, the line goes like this, but it doesn't go through the third point. No, something's up here. These should all be collinear, right? Here's a good example. We have A, B, and C. A, B, and A prime, B prime, and C prime. We can calculate the midpoints for all those guys. I'll just give them to you here. that should look better. Sorry, those were the wrong numbers, weren't they? So here's our line of reflection. You should be able to calculate that line of reflection just based on what it is, right? You can use our graphing skills. Probably the simplest way is to do that y equals mx plus b formula. Here in this case, the slope is -1/2 and b is -1. So it would be something along the lines of y equals 1/2 x minus 1 for this equation. So just be prepared. They tell you can use a protractor to find the lines that are perpendicular. Go ahead and do this one. Yeah. Here are our values here. They give us, let's see, 1, 1, 2, 2, and -2, 2. And then this one gives us the values 5, 5, what's that, 3, 4, and 1, 3. Again, just by looking at these, I kind of expect you guys to be able to do the equation for these lines. This one is y equals x, and this one is y equals, again, if we put it in mx plus b form, we need the slope. So the slope is 1/2 x, and then the y-intercept, which is 2.5 plus 2.5, or 2.5, something like that. Okay, just the last little thing to note is we use reflections when anything bounces. You think of a mirror that's reflecting, that's because light is bouncing off of it, right? So it doesn't have to be light, it could be billiard balls or lasers or whatever. In this case, they're doing mini golf, so it's basically saying that we want to hit it from the tee to hole H, but we can't get it straight there because there's a thing in the way. So at what point on segment CB do we need to aim for, right? So if this is our line of reflection, it's going to bounce off. So we could do this one of two ways. One is we could reflect point T over, or we could reflect point H over. We'll reflect it over. So think of this as a mirror. Here's H prime. If we were to aim for H prime, right, it would bounce off and go in H. So at what point does it cross there? Well, it crosses it maybe 6. Oh, no, that's a lousy way. Let's bounce it off the bottom instead. That'll make it a little more easy, so we don't have any half things. In this case, we'll reflect the T over. So this is T prime. And then we can go that should make it in. In this case, we can check the slope. We go down 1, 2, 3, 4, 5. So down 5 over 1, 2, 3, 4. Well, that's not easy either. So we could bounce it off right about there, or we could bounce it off right about here. Yeah, not the best problem. I'm trying to remember why. Anyway, just be on the eye out for word problems like this where we have to bounce things off other things. I'll be happy to help when we get to that. Thanks. Have a good one.